into two categories. What are the categories that you came up with so far? I'm not saying they're right. I'm not saying they're wrong. No judgment here. I make mistakes every day. Okay? I would expect the same of you too at times. Okay? It's not anything to be worried about. What are the categories that you came up with? Or how did you start to divide them? Yeah. Carlo, right? I'm trying to get these names. Okay, 1-to-1, straight line, and ones that were not. So basically you were looking at, how could we talk about that mathematically? You said 1-to-1 or a straight line. How would you define that mathematically? Linear and non-linear. What do you guys think about that?
I agree.
Linear, non-linear? Yeah, you could put those together. The ones that were linear. I should have looked at that. So graphically, if it's linear, it is a straight line or line segment, right? Okay, so you have those all down. Shoot, where's my cheat sheet? What else do you have over there that's linear? What do they look like? What does the table say?
For the tables, the X input.
Guys, let's listen.
The X input are different numbers than the Y inputs. They're not like repeated numbers. Like there's not more than one X. Like for the X, it could be 0, 1, 2, 3.
Okay.
Instead of it being like 0, 1, 1, 2.
Okay.
And the Y's are different as well.
So you have no repeated X's? Is that what you're saying?
Yeah, no repeated X's. Besides 0.
Okay. What else besides you had the input, output? Tell me about your input, outputs.
The input, output, I mean, they're straight lines to each other. It's not like connecting to another one. It's not diagonal straight lines to each other.
Okay. All right.
And then for the Y, slope form, like.
What form is it? Y equals
MX plus B.
mx plus b. Okay. Over here on this side, do you have an input where all the inputs were the same?
Yeah.
Okay. So what is that input there? So if I go 5, and what's the first number? 5, 7, 5, 8, 5, 9, and 5, 10. What kind of a line is that, or what kind of a graph is that going to make? 5, what is it again? 5, 8, 5, 9, 5 something, 5 something. What kind of a graph is that going to make? A straight line. Oh, so we're not looking at linear versus non-linear, but we're close. Girls up front here, what is it we were looking for? Functions. Functions, okay? So I want you now, keep the cards, or you can probably put the cards all together back in the paper clip, because we might come back to this in a minute. Open up your books to page 3. Open up those prime books to page 3. And on page 3, you're going to see something that looks like this. This is called a Frayer model or a Frayer map. Page 3. The word is function. That is what this whole module is about. Okay? Function. I want you to take 5 minutes, no more than 5 minutes. I want you to either come up with your own definition or Google a good definition for a function. I want you to give me some characteristics of the function and maybe give me some examples or non-examples. Okay? So fill in this page on page 3 a little bit on your own by Googling function. Okay? So this Frayer map or model is just a way to organize the data or information about function. Okay? And I do want you to Google it first. Google it. Think back. What is a function? What's not a function? I'm going to give you I said 5. I'll maybe give you 3 minutes. Because whatever you don't get put in, we're going to put in together. And I will give you some definitions too. Right, Sean? Page 3. Page 3. Cruz, are you all right? You learning through osmosis? Page 3. Conjunction, junction, what's my function? Anybody remember those? They were on the Saturday morning cartoons. I know, they hardly have cartoons on Saturday mornings anymore. It's called Schoolhouse Rock. They did stuff with English, they did stuff with math. It wasn't that funny. That's all right. I know. All right. So at least you have read and maybe seen a little bit. If you don't have anything down, let's jot a few things down together. Who has what they think is a good or decent definition for a function? Anybody? No? So definition, I would say something like this: a relationship where each x has only one y value. Each x has only one y value, something similar to that, okay? Or you could also say each input has only one output. All right? So does that mean it has to be linear? No, not necessarily. Characteristics. When it comes to graphing, there are certain characteristics. Yes, Miss Didi's room. Mm-hmm. She is. Okay, thanks. Ashley, need to go to the clinic. So, first characteristic is graphing.
Wait, what time is the class starting?
What time is what?
The class
36. So, when it comes to graphing, okay, you have to use, oh, come on, the vertical line test. Vertical line test says you can only cross the graph once. Oh, come on. 25, 10, 31. There we go. I know. All right, so vertical line test, it can only cross the graph once. So if you have a graph like this, and your graph goes like this, and you check it with the blue vertical line test, yeah, that's a function.
We don't see that on screen.
Oh, lovely. Okay. I can fix that. Oh, why did that come off? Interesting. Thanks for letting me know. Somehow that got disconnected. Looks like our wonderful internet. Okay, so let's undo this. I really don't want to cancel it though. There we go. Okay, so the blue vertical line test there, that says that the pink line, that is going to be a function. Also, you can do, have a line like this. Okay, that is also a function. Okay, when it comes to tables, does anybody know the rule? Okay, you can have no, what do I want to say? Duplicate x values. No duplicate x values. Okay. And finally, when it comes to equations, your equations are going to be in the form of a linear equation like y equals mx plus b, or they can be as a parabola or a quadratic. So y equals ax squared plus bx plus c. Those would also all result in functions. Okay? So, examples, I already gave a couple over there. Examples of a function. You could also have just line segments. Okay, that would be a function. And we already kind of mentioned these two before. You could have a straight line. You could have a parabola. Those would be functions. As far as a table, okay, you could have 0, 1, 2, 3. This could be -4, 5, 6, 20. Those would all be good examples of functions, okay? Non-examples of a function would be something like an S-curve. So that is not an example of a function. What else? Trying to think. If I had something like this, that would not be a function. Actually, let me take that back. Let's go like this. Sometimes you see that, that is not a function. For a table, let's say I have 0, 1, 0, 2, and I have 2, 3, 4, 5. The reason this is not a function is because you have two of the same x values, okay? So functions. All right, please bring back your workbooks tomorrow and we'll continue talking about functions. No homework yet.